Okay, I want to make a quick review of the derivative before, this may be helpful before we start the partial derivative. So from Calc 1, you probably remember seeing these symbols, dy over dx, change in y over change in x, or f prime of x, the two ways we typically denote derivatives. So in a mathematician, we'll usually say change in y with respect to x. And of course, it doesn't have to actually be y and x, although textbooks use those a lot. So just let's look at a particular example. So let's say I had a function p of t. So it's not y or x, but it's the same concepts. And p of t represents the profit in thousands of dollars t days after releasing a new smartphone. So maybe this is a Samsung or somebody's estimates of their profit t days after they release some new phone. Okay, so I've got two statements that I would want you to think about for a second. P of t equals 23.4, and p prime of t, or the derivative at t at 10, is 2.3. So they're all evaluated at 10. So the first thing, both of those, they've got to be something different. And a lot of times students will write answers that look very much the same for both of these concepts. They'll say profit at day 10 is 23.4 times $1,000, so $23,400, and that is actually correct. But then they'll look at the next one and they'll say the profit at day 10 is 2,300, 2.3 times 1,000. Well, how the heck can the profit be two different numbers on the same day? Obviously, the profit is what it is, and it's one answer. So we have to refer to what the derivative is. It's the change in the top variable over the change in the bottom, or the change in the function over the change in the input. So the correct way to interpret this, the derivative, would be, so it's 2.3 times 1,000, so it is 2,300. So it's $2,300 per day, since t is measured in days. The units of the derivative are always units of the function over units of the input. Whereas this one is indeed, profit is $23,400. Profit on day 10. So the profit is $23,400. Now something is $23,400 per day. That is the change, the instantaneous change at day 10. So the profit is increasing by $2,300 a day. So we're making $23,400 and our profit is increasing. We expect to make even more on day 11. In fact, if you had to estimate it, you'd say, well, I'll probably make $2,300 more on day 11, and you would add that to the prior number. Now, depending on your calc teacher, you may have to spend more time actually just doing, quote unquote, doing derivatives. This is about understanding derivatives, and that's very important to me, and that'll be important in the partial derivatives. And doing derivative is sort of the traditional calculus problems. You have a function like s of x or y or whatever, it doesn't matter, the variables, 20 is equal to 20x cubed plus 60e to the negative 0.23x. In a traditional calculus class, you spend a lot of time learning to do these by hand. I am less interested in that as time goes on. Wolframalpha will do that problem easily. Siri on my iPhone will do that pretty easily. And etc. Who knows what we have in another year or two. Maybe Google Glasses will just look at it and give you the answer. So the actual importance of doing the traditional math by hand is becoming less interesting to me. If you wanted to do it by hand, if I've done it right here, it would be 60x squared plus, and then the negative 0.23 would come down. So there's our function. And then if you wanted to evaluate it at 5, I'm going to show you how this would look on Wolframalpha. This one you could do on a TI-83. You could graph the function and pull up the derivative and plug in the number 5, and the TI-83 would tell you. This first one here you couldn't. The TI-83 will not give you the general derivative formula. But Wolframalpha certainly will. So I close this window and open up this one. And I might need to move it just a little bit. So there's where I've typed in derivative of x cubed plus 60e, the whole function there. And we get an answer of 60x squared minus, it combined the numbers together, same answer I got by hand. Just that easily by typing this into a free version of Wolframalpha. If I want to know the value at 5, I put a comma, x equals 5. And we'll now evaluate that derivative at x equals 5, and it gives me a numerical answer. And then, handily enough, it also gives me a graph of what the function looks like, and it puts the spot 5 on there for you to see. So that's sort of the power of Wolframalpha, and one of the reasons why I'm less interested in worrying about your skills at doing a derivative by hand and more interested in you understanding that the derivative is the rate of change. Whatever the function was in this case, it is increasing by 1495.63 per 1 unit of whatever the input function is. So hopefully this review is helpful so as you get ready to do your partial derivatives. Partial derivatives are very much the same, only then you have a function of more than one variable, and you're thinking about how it changes in relation to one variable changing at a time. So you'll let x change and see how the function changes, then you'll let y change and see how the function changes based on y. Hopefully that's been helpful. Have a great day and good luck with your homework.